Okay, so this lesson we're going to simplify complex fractions, and there are two methods that we're going to use. There's a method called method 1, and then method 2 we're going to look at in the next lesson. Now you've dealt with complex fractions before, so the easiest type of complex fraction that you dealt with was something like this. So here's an example of a complex fraction that you dealt with. So, for example, you had something like, let's say, 7/6 divided by, and let's say 4/3. All right, so that's a complex fraction. And you dealt with this multiple times in the past, many times in the past. So we'll come back in a little while and remind ourselves, well, how do I deal with this kind of complex fraction? But before we do that, let's look at the definition of a complex fraction, because in this lesson we're going to be dealing mostly with variables rather than just whole numbers. So we're dealing with variables. So let's look at the definition of a complex fraction. All right, now we're going to be dealing with complex rational expressions, sometimes called complex fractions. Now here's the definition. A rational expression whose numerator or denominator or both numerator and denominator contains fractions. So if I look at the one that I just mentioned to you that you've dealt with before, notice the numerator has a fraction in it and the denominator contains a fraction. All right, so that makes it a complex fraction. And so here's some examples. Notice that these look more complicated than the one that you've dealt with before, but it's necessary that you remember how to do this because these in method 1 will end up looking something like this. All right, so notice that this is a complex fraction because the denominator here has a fraction in it. In fact, you can think of 4 as a fraction as well, couldn't you? Because that's 4 divided by 1. And then the same thing here, that's 3 divided by 1. So notice you have a fraction here, a fraction here, a fraction here. So here's another complex fraction. Notice that we have a variable though, okay? Notice you have another complex fraction, and we have variables in this case in the denominator as well. So here, the variables in the numerator, your denominators contained whole numbers. Here, your denominators, some of them contain variables. So you're going to be dealing with a multiple of these types of situations. Okay, now, our goal when dealing with complex fractions is that we want to write a complex fraction in simplest form. So when we talk about this right here, when you're in the past, when you dealt with this, you wanted to write this in simplest form. So I'm going to say write in simplest form. Write in simplest form. All right, so basically you're going to divide those two rational numbers, those two fractions. That's what you're doing. So you're taking this fraction, and then you see the division bar right here, that long division bar. So you're dividing it by this fraction. A complex fraction is in simplest form. So let's talk about what we mean by simplest form. So a complex fraction is in simplest form when it is in the form p divided by q. So notice one simple looking expression where p and q are polynomials that have no common factors. And so we're going to talk about this idea. We're going to talk about this idea with this. So let's talk about this right here. Now, before we do this, let's remind ourselves about this situation. So let's remind ourselves, how do we deal with this? So when we talked about 3/10 divided by 9/2, how'd you deal with this in the past? So when you had 3/10 and you were dividing it by 9/2, do you remember that you had to change the division to multiplication? And so when you did that, you said 3/10 says equal 3/10 times the reciprocal of the fraction following the division symbol. So times the reciprocal, and the reciprocal of 9/2 is 2/9. Okay? Now, here's what some people are going to do. So some people are going to go ahead and multiply. They're going to say, well, I'm going to multiply the numerators together. 3 times 2 is 6. And I'm going to multiply the denominators together. 10 times 9 is 90. All right, now let me remind you about a common error that some students will make. So they will, at this point, find the least common denominator. You don't do that. When is the only time that you deal with finding the least common denominator at this point that you've learned? You find the least common denominator when you add or subtract rational expressions. Am I adding or subtracting these two rational expressions? No, I am multiplying. So do not start looking for the least common denominator. You just multiply the denominators together. That's all you do. All right. So be careful. Don't write these two. Don't write these two with a denominator of 90 or whatever other common denominator you want to use. Okay. So be careful. The only time you find the least common denominator is if this is addition or subtraction. All right. So we get this. Now here's the thing. So let's go back to this right here. So a complex fraction is in simplest form when both the numerator and the denominator, so P and Q, polynomials. And remember, a monomial is a polynomial. So I do have a polynomial and I have a polynomial. It's just a monomial. And in this case, the monomial is just a whole number. They have no common factors. Do these two numbers, 6 and 90, have a common factor? Sure they do. The common factor is well, we could say 3, right? We could say 3. That's a common factor. What's another common factor? 2, right? Okay. What's another common factor? 6. So I'm going to go ahead and do 6. So both of those are divisible by 6. And so that's the idea. You got to make sure in the end, when you're dealing with this, that this is in simplest form. So you need to make sure that your final answer is in simplest form. So both of those are divisible by 6. So that's going to equal, I'm going to go ahead and do it this way. Divide by 6, divide by 6. And so I get 1, oops, that's a 90. So I get 1 divided by, and then 90 divided by 6 is 15. So I get 1/15. Okay? Now remember though, the other thing you should have done, really, instead of multiplying numerator first and then denominator, remember what you've learned in the past was that when you got to this point, 3/10 times 2/9, when you got to that point, you reduce first. So 3 into 3 is 1, 3 to 9 is 3, 2 into 2 is 1, 2 into 10 is 5, and then you multiplied. So 1 times 1 is 1, 5 times 3 is 15. All right, see how much easier it is to reduce first and then multiply? Okay? Now when we get to this point, that's the same idea as this. So notice I'm saying in words, I have 7, 6, and I'm dividing by 4/3. So 7, 6 divide by 4/3. So basically you're going to change this to multiplication problem. So you take the fraction that's in the numerator and you're going to multiply by the reciprocal of the fraction that's in the denominator. So the reciprocal 4/3 is 3/4. Okay? Now at this point, before you multiply numerators and before you multiply the denominators, let's reduce. So it looks like the only thing I can reduce are the 3 and the 6. So that 3 and 6, they have a 3 as a common factor. So 3 into 3 is 1, 3 into 6 is 2. Notice I'm writing the 1 and the 2. It's important you do that. And so 7 times 1 is 7, and then 2 times 4 is 8. Okay? So that's the idea that you're going to use. All right? Now, again, we're going to use what's called method 1. Now, in the end, method 1 is going to involve this idea. So it's important you remember how to deal with one fraction divided by one fraction. Okay, so let's talk about method 1. So method 1 involves this idea, and we're going to look at each step as we go through the process. But this is method 1. Let me go ahead and decrease the size here. So we're going to look at two methods. Method 1 is the first, is going to be this lesson. So in method 1, step 1 is to simplify the numerator and simplify the denominator of the complex fraction so that each is a single fraction. So in other words, you want to get the numerator to be one fraction and you want to get the denominator to be one fraction. Okay? Step 2. Then perform the indicated division by changing the multiplication problem. So you're going to multiply the numerator of the complex fraction by the reciprocal of the denominator. And that's what we did here. So once we get to this point, then you're going to change this multiplication problem. So you're going to take the fraction in the numerator, multiply by the reciprocal of the denominator. And then you simplify if possible. Okay, so that's step one. So it's not that bad. As long as you remember this idea in the past, you should be okay. And you got to remember some things about how to factor polynomials and so forth. Okay, so let's look at the first one. So we're going to start with an easy one. So let's look at this idea. So let's look at. So the directions will say simplify, or they could say divide. But in the end, with that, whichever direction they use, whichever the directions are there, just make sure you simplify. Chances are it will probably say just simplify. Okay? All right, so let's look at number one. We're going to call this number one. All right, number one. So we have 1/5 plus 1/2 divided by 4/7 minus 1/14. All right, so notice this is a complex fraction. I have the numerator contains one or more fractions. The denominator contains one or more fractions. All right, and it doesn't have to be both numerator and denominator contain fractions. It could just be one or the other. So the first thing you got to do is this now. So remember, the idea is to rewrite the numerator as one fraction, as a single fraction, and rewrite the denominator as a single fraction. So here's the idea. You need to, if you have to, you need to cover up the denominator part. All right, and then ask yourself, off to the side if you need to, just think about this. So I'm going to go ahead off to the side. I'm going to do the work. So I'm going to think, all right, I have 1/5 plus 1/2. So go off to the side. That's important. You got to think about your thought processes, and so go off to the side. So what you want to do is you want to add those two fractions as one fraction. So you got to find the LCD. So the least common denominator is 10. And so I'm going to write equivalent fractions. So I'm going to write two fractions with a denominator of 10. All right, and then you're going to ask yourself, and so notice that should look familiar. We dealt with this in previous sections with variables. So I got to multiply this denominator by some number to get 10, because I want to write equivalent fractions. So 5 times 2 is 10, but remember what you do to the denominator, you do to the numerator, because you need, remember, 2 divided by 2 here, 2 divided by 2, 2 divided by 2, that's 1. And so I get 2 times 1 in the numerator is 2. And you can always check, if I reduce 2/5, I get 1/5 back. All right, so I'm going to put this in black right here. And we do the same thing here. So 2 times 5 is 10. 1 times 5 is 5. So that goes here. So notice 5/10 reduced is 1/2. Let me go ahead and enlarge this a little bit better. Okay, and so therefore now I can write this as one fraction, and so I get 7/10. And that's the numerator. So that's the idea. So the first thing I did was I figured out what one fraction these two fractions add together is equal to. So that's going to be 7/10. All right, so that's my numerator. So again, remember, the goal when using method 1 is to write the numerator as one fraction, and then write the denominator as one fraction. And then remember, you got to go off to the side and do some work. So there's still some work you got to do. But that work here is prior knowledge from previous lessons that we talked about, especially in these lessons when we talked about simplifying rational expressions. Okay, so that's where we had to write equivalent fractions. So all that's still coming to play. All right, so let's look at the next one. So now I'm going to go to the denominator. All right, so let's look at this one now. So now we have 4/7. Do the same thing with the denominator. So 4/7 minus 1/14. So what's the least common denominator of 7 and 14? Well, the least common denominator of 7 and 14 is 14. So I'm going to write two fractions with a denominator of 14. So 4/7 is equivalent to what fraction with a denominator of 14? 1/14. Remember, a rational number, a fraction, is always equivalent to itself. So you see, I already have a 14 here, so what goes here? 1. And you knew that had to be the case because 14 times 1 is 14, and then 1 times 1 is 1. And over here, same thing, 7 times what's 14? 7 times 2, and then 4 times 2. So what numerator goes here? 8. And you can always check because 8 and 14 are divisible by 2. And so if I reduce this, I get this back. So now I can write this as one fraction. So that's going to be a fraction with a denominator of 14. And 8 minus 1 is 7. Okay, now let's go ahead and reduce this at this point. So let's reduce it. So 7/14 is what? 1/2. So I get 1/2. And so that's going to go here. Now I'm going to say this. If you left this as 7/14, no big deal. No big deal. I'm going to do it both ways just to show you. At the end, though, your final answer, you got to make sure it's simplified. Your final answer, you got to make sure. See that 6/9? You got to make sure in the end that's simplified. Okay? All right. Now, once you get to that point, what's the next step? The next step is to change this to multiplication. So that's step 2. So step 2 is to perform the indicated division by changing the multiplication problem. All right, step 2. So I'm going to get 7/10 times the reciprocal of the denominator, which is 2 divided by 1. And then let's go ahead and reduce. 2 divided by 2 is 1. 2 divided into 10 is 5. So 7 times 1 is 7, and then 5 times 1 is 5. So there's your answer, 7/5. Okay. Now I just want to say this, and I'm going to go ahead and do that here. Do you see that 1/2 I received just after I reduced? But if you had used 7/14, I just want to show you something. So notice, but this is notice. Suppose you said 7/10 divided by 7/14 instead of 1/2. No big deal. Notice what happens. Same idea. The numerator, the fraction of the numerator, times the reciprocal of the denominator, so 14/7, right? And then let's reduce. 7 to 7 is 1. 7 to 7 is 1. 14 and 10, they have a 2 as a common factor. So I get 14 divided by 2 is 7. 10 divided by 2 is 5. And then notice what happens. 1 times 7 is 7. 5 times 1 is 5. And notice you get the same thing. So again, it doesn't matter if you reduce at this point or you reduce in the end, but the final answer must be in simplest form. So that's your answer, 7/5. All right, so let's look at number 2. So that's method 1. So method 1 involves you taking the numerator, writing as one fraction, taking the denominator, writing as one fraction. That's method 1. All right, let's look at another one. So this is going to be number 2. So let's suppose number 2, I had this in number 2. All right, so that's number 2. So let's see real quick. All right, so let's do one with a variable in the denominator. So I have 2/5 minus 1 divided by x divided by 2x divided by 15 minus 1/3. All right. Okay, so don't let that throw you off. You know how to deal with this because you've had enough experience. You've had enough experience to be able to simplify these two rational expressions into one, and then do the same thing with these. All right, so remember, we're doing method 1. So method 1 says I take this numerator right here. So I'm going to go off to the side. It's important you do that. You must do your work. You must do your thought processes on the side. All right, so let's think about how to write this as one fraction. So I got to find the LCD. So this LCD is easy. So that's easy to see that the LCD is 5x. So your LCD is 5x. And so now I'm going to write two fractions with a denominator of 5x using that denominator, using that LCD. Okay? And so notice I want to write equivalent fractions. Notice the word, remember, equivalent fractions. Equivalent fractions. And we talked about that in previous lessons. So you got to ask yourself, all right, I have a 5. I want my denominator to be 5x. So what do I need to multiply 5 by to get this denominator? Well, I need to multiply by x. But remember, what you do to the denominator, you must do to the numerator, because you got to keep 2/5 still 2/5, and x divided by x is 1. So that brings us back to our lessons when we talked about simplifying rational expressions. So now the numerator is 2 times x, which is 2x. So I'll put 2x here. Okay? Now let's look at this one. So what do I need to multiply x by to get 5x? So I need to multiply by 5. But what I do to the denominator, I do to the numerator. So 1 times 5 is 5. Okay? And so now I can write this as one rational expression with that denominator, 5x. And so my numerator is just 2x minus 5. And I cannot combine those terms, so I leave it as that. So notice I wrote the numerator. I want you to see this. I wrote the numerator as one fraction, 2x minus 5 divided by 5x. Okay? All right. Now let's look at the denominator. So I go off to the side and I do the denominator now. I do this part. I do this part. So I got to write this as one fraction. So notice I have two fractions as subtracting. I want to write as one fraction. So I go off and I do that. So I write it out. 2x divided by 15 minus 1/3. You'll see that? All right. So now again I got to find the LCD. So what's the least common denominator of 15 and 3? Yep, the least common denominator is 15. And remember, always use the least. Don't say 30. Although 15 goes into 30, 3 goes into 30, that's not the least. There are an infinite number of common denominators, common multiples of 15 and 3, but the least is 15. It makes things so much easier for you if you use the least. Okay, so 15. So now I'm going to write two rational expressions with 15 as my denominator. Notice there's a 15 here. I already have the 15. So remember, every fraction is equivalent to itself. So if the denominators are the same, then the numerators have to be the same. And that kind of makes sense because I'm saying 15 times 1 is 15, and then 2x times 1 is still 2x. Okay, so it does make sense. For 3 times 5 is going to be 15, but again, what I do to the denominator, I have to do to the numerator. And so 1 times 5 is 5. Okay? And so there's my and now I got to write this as one fraction. So that's going to be 15 as my denominator, and then 2x minus 5 as my numerator. So that is going to go here now. So 2x minus 5 divided by 15, right? Divided by 15. Okay, now, once you get to that point, now you see, it's just kind of like this, right? So you have one fraction divided by one fraction. One rational expression divided by one rational expression. So now you're going to change this division to multiplication. Same thing here. You have one fraction, you can see it, cover the denominator up. You have one fraction divided by one rational expression, one fraction. So now I'm going to change this to a division symbol. So that's going to be 2x minus 5 divided by 5x times the reciprocal of this. So 15 divided by 2x minus 5. Okay? Now remember, we talked about this before. It is so much easier to reduce first and then multiply the numerators and then multiply the factors in the denominators. So what that means is this. Don't multiply these out first. Reduce first. You can see they can reduce. You've dealt with this a long time ago when we first started talking about these topics dealing with rational expressions. So 2x minus 5 divides into 2x minus 5. So you get factors of 1 in their place. Now let's look at the next factor that I see is 15. Will 15 reduce with any factor that's in the denominator? Yeah, I have a factor of 5. So 15 and 5, they both have a 5 as a common factor. So 15 divided by 5 is 3. 5 divided by 5 is 1. And that's all I can do. So now my answer is going to be 1 times 3 is 3. 1 times x times 1 is x. So there's your answer, 3 divided by x. So there's a lot of moving parts here, a lot of parts to get through this, a lot of things that you have to remember from previous courses and even from this course that you learned in these lessons. All right, so that's number 2. So again, that's method 1. So method 1, remind you, method 1 is to take the numerator, write it as one rational expression. You got to do some work though. You still have to do some work. And then do the same thing with the denominator. Take the denominator, do your work, and write it as one rational expression. And then once you get into one fraction divided by one fraction, then you change this division to a multiplication problem. And then you reduce, and then you multiply. All right? Okay, number 3. Number 3, let's suppose we had this for number 3. So let's see. Number 3, we have 2 divided by y plus 3 divided by 1 divided by y minus 2. All right, so let's suppose we had that. Okay, so again, remember, you want to make sure in method 1, you want to make sure that the numerator is one fraction. Notice I have two fractions up here, 2 divided by y plus 3, and you can write 3 as 3 divided by 1. Okay, so let's go off to the side and then do the work. So 2 divided by y plus 3 divided by 1. I'm going to write it as 3 divided by 1. So what's the least common denominator of y and 1? Well, the least common denominator is y. And so I'm going to write 2 rational expressions with that denominator y. So I want to determine 2 divided by y is equivalent to what fraction with y as the denominator? Well, the denominators are the same. So 2 divided by y is equivalent to itself. Now let's look at this one though. Here I have a 1 and I want it to be a y. So 3 divided by 1 is equivalent to what rational expression, what fraction with a denominator y? Well, all I need to do is, in order to get y, is to multiply this by y. But what I do to the denominator, I got to do to the numerator because I need this right here to be a 1. And so my numerator now is 3 times y, which is 3y. And so now once you write your equivalent fractions, you see you have the same denominator. So now you can write this as one fraction. So I get 2 plus 3y, or you can say 3y plus 2, does not matter. So that's going to be your numerator. So my numerator, see I wrote the addition of two fractions as one fraction. So I'm going to get 2 plus 3y divided by y. So that's the numerator. So now I'll go in and do the same thing with the denominator. And you see there's some work you got to do though. But that your thought processes are going to come from your previous experience, your previous skills that you've learned. Okay, so 1/5, 1 divided by y minus 2. I'm going to write this as 2 divided by 1. So again, the LCD is y. You see that? LCD is y. So now I'm going to write 2 fractions with y as the common denominator, as in this case my least common denominator. So notice this is already a y. So 1 divided by y is equivalent to itself. Over here, I'm going to have to multiply this one by y. And so if I multiply the denominator by y, I've got to multiply the numerator by y as well. So my numerator is 2y. So now once I write my two equivalent rational expressions, they now have the same denominator. I can now write this as one fraction. So it'll be 1 minus 2y. And so that's going to be the denominator. So my denominator will be 1 minus 2y divided by y. All right. Now again, once you get it as one fraction divided by one fraction, you're now in step 2. So all this was step 1. So step 1 was where you had to do some work to get the numerator to be one fraction and the denominator to be one fraction. Step 2 is actually where you change division to multiplication. All right, so now I'm going to take the top fraction, the fractions in the numerator. I'm going to, remember this is division, so I'm going to change the multiplication problem. So it'll become 2 plus 3y divided by y times the reciprocal of this. So if you need to cover up some parts of the problem that distracts you, then do that. So you got to take the reciprocal of this now. So that's y divided by 1 minus 2y. And now let's reduce before we multiply. So the only thing I can reduce here are the y's, just like this. And I can't factor anything else out, so that should be the answer. So 2 plus 3y times 1 is 2 plus 3y. And then 1 times 1 minus 2y is 1 minus 2y. So there's your answer. And it's all you do. Okay, so it's not that bad. It's really And the reason it's not really difficult is because of your prior knowledge. You have enough information in your toolbox to be able to go through these processes. Okay, let's look at another one. So this is going to be number 4. So number 4, let's suppose we have this in number 4. We have 6 plus 3 divided by x divided by x divided by 4 plus 1 divided by 8. All right, so 6 plus 3 divided by x, and in the denominator I have these two fractions that I'm adding together. So x divided by 4 plus 1 8. So again, method 1. So method 1, remember, is where you take the parts that's in the numerator, so you kind of cover this part up, and you go off to the side, and you figure out how to write this as one fraction. So you got to find the LCD, because you remember you can't, in order to add two fractions or subtract two fractions, you got to have the same denominator. So I got to find the LCD. So the LCD here is just x, and so I'm going to write two rational expressions with that denominator. And so this right here, that part's easy. So 3 divided by x is equivalent to itself. And again, that makes sense because x times 1 is x, and then 3 times 1 is 3. Over here, though, I got to multiply 1 by what expression to get x? Well, 1 times x. But what I do to the denominator, I have to do to the numerator. So 6 times x will be 6x. And now I can write this as one rational expression. So I'm going to get 6x plus 3 divided by x. Since the denominators are the same, I can just add the numerators together. So that's your one fraction. So that's going to be the numerator now. So 6 plus 3 divided by x is equivalent to this. So I get 6x plus 3 divided by x. Now I'm going to divide this by this part. So again, method 1 says I got to take this part here, which is x divided by 4 plus 1 divided by 8, and I've got to write this as one fraction instead of the addition of two fractions. So the LCD here is 8, right? LCD is 8. So I need to write two fractions with 8 as a denominator. So notice that 1/8 is already equivalent to itself. For this one, I got to multiply 4 by 2 to get 8, and what I do to the denominator, I do to the numerator. So my numerator is 2x. And so therefore, this becomes 2x plus 1 divided by 8. So now I can write this as one fraction. Now, remember, don't make your mistake and say 8 plus 8 is 16. Okay, you can't do that. Whenever you add or subtract fractions with a common denominator, that fraction you end up having has to be that denominator. Okay, so then this is going to go here. So I have 2x plus 1 divided by 8. All right, now step 2 says once you get one fraction divided by one fraction, step 2 says you change this to a multiplication problem. So now this becomes 6x plus 3 divided by x times the reciprocal of this, 8 divided by 2x plus 1. All right, now remember the next part is to reduce, but before we reduce, notice I can factor out a 3 here, right? So you need to do that. If you can factor any of your factors any further, you do that. So in all the problems we've done previously, I could not do that. So once I got to that point, your factors were already factored as far as they can be factored. So now we're at a point where I can see that I can factor this numerator further. And so notice I'm going to write this as 3. I can factor out a 3. So it's a good idea, guys. It's a good idea to actually take the time and rewrite this. Don't put too much writing in this area. All right. So the more writing you write out, the harder it is to visually see stuff. So that'll be 3 times 2x plus 1 divided by x times x divided by 2x plus 1. And now you see you have some common factors. So it's very important when you get to this point, before you reduce, you check to see if you can factor further. So I can reduce. And so it looks like the answer is 3 times 1 times 8, which is 24, divided by x times 1, which is x. So there's your answer. All right, so see, it's not that bad. It's not that bad. let's see if I have time to do one more for method 1. And yeah, let's go and do one more. I just want to do one more just to give you a little bit more practice with method 1. Okay, so in let's say we had this situation. So we have 1 divided by 3 plus 1 divided by x plus 4, and that's being divided by x plus 7 divided by 9. Okay? All right. Now, so I want you to notice something. Do y'all see that my denominator is already one fraction? Y'all see that? Okay. So I don't have to do anything with the denominator. With that work I have to do on the side, I'm good with the denominator because that's one fraction, right? Okay. Now look at the numerator. Now I got to do something with the numerator though, because that's not one fraction. That's the addition of 2 fractions. So let's go off to the side and deal with that. So 1 divided by 3 plus 1 divided by x plus 4. All right. So remember, when adding 2 fractions when the denominators are the same, you got to find the LCD. Now notice that this is a polynomial. You got to remember some things you did in the past. You got to factor if possible. So I cannot factor this. So now you know that the LCD pretty easily is 3 times this. So it's 3 times x plus 4. Now remember, always leave the LCD in factored form. Don't distribute. So I'm going to write 2 fractions with this as the LCD. So 3 times x plus 4, 3 times x plus 4. Okay? And so now I'm going to go ahead and write equivalent fractions. So 3 times what will give me this denominator. So what's missing? I already have the factor 3, so what is that I need here? The factor of x plus 4. So I got to multiply this by x plus 4. But what I do to the denominator, I must do to the numerator. Okay? Now put it on this side because I didn't have enough room over here. But remember, x plus 4 times 1 is the same as 1 times x plus 4. X plus 4 times 3 is the same as 3 times x plus 4, right? Okay, so then I get x plus 4 times 1, which is x plus 4. And it kind of makes sense that this is true because if you reduce the x plus 4s, you get 1. If I reduce the x plus 4s, you get 1 divided by 3, which is what this was. Over here, what's missing over here? So I have the x plus 4. What is it that I need? To 3. So I got to multiply this by 3 and this by 3. And so therefore, 1 times 3 is 3. That's the numerator. So now I can write this as one rational expression, 3 times x plus 4. And then notice the numerator. This is addition, so that's an easy one to deal with. So x plus 4 plus 3 is just x plus 7, because 4 plus 3 is 7. So that's going to be the numerator. So my numerator is x plus 7 divided by 3 times x plus 4. And the denominator, I don't have to do anything with because that's already one fraction. All right, once I get to that point, once I get one fraction divided by one fraction, then I change this to a multiplication problem. So this becomes x plus 7 divided by 3 times x plus 4 times the reciprocal of this, so that's 9 divided by x plus 7. And then just make sure every numerator and every denominator is factored as far as you can go, and it is in this case. And now let's reduce. The x plus 7's divide out, and that's all you can, oh, and the 3 and the 9 you can reduce. So 3 and the 3 is 1, 3 to 9 is 3. See that? And so therefore, and I can't reduce anything else, so therefore your answer is going to be 1 times 3 is 3. 1 times x plus 4 times 1 is x plus 4. And so there's your answer. Okay, so method 1. And method 1 is not going to be an issue only because of your prior knowledge. So everything you've learned from a previous course, such as these, okay, to learning now how to write equivalent fractions when you have variables in the denominator, and you learned that in a previous lesson in this course, will get you through method 1. And that's method 1, so it's not that bad. Okay, that'll be the end of this lesson.